Hi guys. So we're Team2, and our project is a robot that can pick teeth. So our goal, you might remember from the first, the lightning talks, but our goal is to make a robot that can basically, you give it a teeth plant, and it's able to find the part of the teeth plant that we want to extract, and reach and extract that part. So there are going to be two components to our project. There's the computer vision part, where we're going to have a camera that is going to see and identify which part of the plant we want. Myself and Pete, we're going to be handling that sort of more software-oriented part. And then the second part is the mechanical part, where we have the actual arm that's able to go through the motion, the picking motion. And Eileen and Fari are going to handle that part. And eventually we're going to have to merge the two parts together. So right now our team, we're just we communicate through messaging, just sort of quick communication. We also have sort of a drive where we have all the notes, links, sort of useful things that we need for the project. And then our advisors are Dr. Taylor. He's in the SIS department, and he is in robotics. He actually does a lot of research on computer vision, so he's really helpful for this. As well as Dr. Sun, who deals with more sort of mechanical systems, and she's really helping with sort of how, understanding how the robot arm has to move. So the next thing we're going to talk about is...
So the project components that we have, like Brandon previously described, is going to be the software part and then the hardware part. And within the software components, we're going to need probably use MATLAB and Python to handle a lot of the computer vision and like deep learning side of things. And also we might use MATLAB to control the movement of the robotic arm to send like serial commands to the arm and like instruct it on how to move. And then we're also going to have to use C on the microcontrollers in order to also control the movement of the robotic arm. And then from the hardware side, we're going to use Intel RealSense camera. At least this is what initially what Dr. Taylor has recommended to us, and that's like a $200 stereo camera that has an RGB camera as well as a depth camera in order for us to map out objects in a 3D space. In terms of the robotic arm, we were originally planning on just purchasing an existing sort of hobby arm, but after talking to Dr. Sung, she says that the best kind of robotic arm we should use is probably a Delta robot, and they only sell those in very industrial grade settings, which cost thousands of dollars, which we're not going to approve by Senior Design. So we found we went online and found pre-existing designs that other hobbyists have created, and we found some SolidWorks files that we can hopefully recreate ourselves and create a first prototype of our product. And then we're also going to need servos to control the movement of the arm, and then microcontrollers, and we're going to purchase some plans for testing our project on, and then hopefully the budget will fall within the $400.
So here are our fall milestones. Currently, the mechanical team is organizing the parts, like ordering and printing the parts. And the software side, we're setting up the infrastructure for our basic image recognition software. For the MVP demo in early November, we should have a basic arm kinematics program and a basic image identification program ready. Between the MVP demo and the 4 minutes presentation, we look to keep refining both the arm and the image recognition side to be more precise and accurate. By the 4-minute presentation, our robot should have the capability to move in like a human-like motion, and our image recognition software will begin testing those on actual plants. So our final goal for the final fall demo is to integrate both parts, and our robot should be able to identify the parts of the plant we want to extract and move the hand in and extract the parts.
Okay, so I'm going to talk about the sprint milestones. So the first part is we hope to then work on refining image recognition. Essentially, our problem is being able to identify one green leaf from another green leaf. So we do not anticipate that that's going to be an easy task. So the goal is to be able to take repeated readings and make sure that we are able to do that precisely in terms of like our image recognition. And in terms of like the robotic arm, after doing thorough research, we realized that we are going to assemble our own Delta robot. So part of it is going to be like making sure that this robot that we are assembling is very strong. It can easily grasp our leaf and it can perform the functions that we want it to perform without having any problems. We anticipate that it's going to be a lot of relearning and trial and error and adjusting the dimensions of our robotic arm and in terms of just like everything all together. The other focus is on the just putting everything together. So essentially we are divided into two groups, the hardware part and the software part, just making sure that everything works together and there is no lag between these two systems, and also making sure that when we have our final product, it is strong, it can work as an independent product, and all our software has been transferred to the robot instead of like controlling everything from our laptop, which is what we'll be focusing on during the first semester to make sure that we simplify the problem and stuff.